Welcome to Maths with Jade. In this video tutorial, we will be doing Pythagoras' theorem. We will learn how to find a missing side of a right angle triangle given the other two sides. So if I know this side and this side, using Pythagoras, we can find this side. And if I know this side and this side, we can find this side. I think you get the idea. So it's time for a quick history lesson, but you can skip to 1 minute 30 of this video if you are not interested and just want to do some maths because that's what you came here to do. So this is Pythagoras of Samos. He was born around 500 BC. And he was a Greek philosopher / mathematician who was obsessed with numbers. He had his own school, but formed his own religion, and that school quickly became a cult. He was a vegetarian and responsible for a whole vegetarian movement. He probably wasn't a nice guy because he was rumoured to have murdered another mathematician at a similar time to him. Basically, if you see your maths teacher walking down the street, smile politely and run the other way. The worst part is he probably didn't even discover the theorem that was named after him because the Babylonians were using it 1,000 years before he was even born. So let's take a look at this theorem, Pythagoras' theorem, apparently. So it's based on a right angle triangle, and the most important thing we need to do first is identify the hypotenuse and call it C. The hypotenuse is the longest side on a right angle triangle. And if you can't spot the longest side, then just know that it's opposite the right angle. The other two sides are labelled A and B in any order. So Pythagoras' theorem states that if we take A and square it, and then take B and square it, plus those two together, then we get C squared. C being our longest side. So A squared plus B squared equals C squared. That is Pythagoras' theorem. Let's see how to use this in practice. So I have a right angle triangle, I know two of the sides and I want to find x. First, identify the longest side, the hypotenuse, and call it C. The other two sides are A and B in any order, either way around. So Pythagoras' theorem, here it is. And we want to substitute in the information from the triangle into Pythagoras' theorem. It gives us 6 squared plus 5.1 squared equals x squared. And now let's simplify. So 6 squared plus 5.1 squared gives me 62.01. Now square root both sides. Make sure you have a calculator handy. The square root of 62.01 gives me 7.874642. Round that to 3 significant figures and I get x is equal to 7.87 centimetres. So that's finding the longest side, and it is the same every single time if your unknown is C, the hypotenuse. Let's now look at finding a shorter side. So here's the situation where our unknown is one of the shorter sides. First step again is identify the hypotenuse and call it C. The other two sides can be called A and B in any order. Now here's Pythagoras' theorem. Substitute in the values from the triangle and we get x squared plus 58 squared equals 90 squared. To solve this equation, we need x on its own on one side. So we're going to subtract b squared from both sides. And in this case, we will be minusing 58 squared. So it cancels out on the left-hand side, and on the right-hand side, we're left with 90 squared minus 58 squared. Now we can simplify. So find out what that right-hand side gives us, and then square root both sides. And we have found our value of x, which is 68.8 metres rounded to 3 significant figures. So it's time for a quick summary. To find the longest side, we plus together the square of the shorter sides, and then we square root. So to find a shorter side, we subtract the square of the known shorter side from the square of the longest side, and then square root. Here's a little task for you. Find the missing lengths in the following right angle triangles. Pause the video now. Here are the answers rounded to 3 significant figures. Now let's solve some problems with Pythagoras' theorem. Here's a cat and it's stuck in a tree. A fire engine comes along to rescue it. The cat is 9 metres high in the tree and the back of the fire engine is parked 4 metres away from the base of the tree. It has 10 metres of ladder it can roll out. Can the cat be rescued? Let's put on the information that we know. The cat is 9 metres high in the tree and the base of the fire engine is 4 metres away. We want to find that distance to save the cat. So this is our unknown. However, a question mark is not a good variable, so get rid of that and give it a variable that's suitable, like D for distance. Our problem is a right-angled triangle, and we want to find the longest side. So to find D, I square the two shorter sides, plus them together, and then square root. It's as simple as that. And I get 9.8488578 meters. Which means yes, the cat can be rescued because the distance is less than 10 meters, which means the ladder will reach. Here's lots of quite challenging questions for you to be getting on with. Good luck. Pause the video now. So the first 3 questions should have been quite straightforward. If you got one of them wrong, go back and check your diagram. For question number 4, you should have got an x distance of 8, 0 to 8 is 8, and then 4 to 10 is 6, which means we're finding the longer side, you should have got 10. For number 5, we had an x distance of 8, and then a y distance of 9. However, it's actually minus 9, it goes down, but distance is always positive. Longest side is 12.0 to 3 significant figures. And they start to get a bit harder now. You want to find the height to find the area, so split the triangle in 2, and you do have a right-angled triangle with a base of 15. You can use Pythagoras Theorem to find the height, and you should have got 25.98, it's the shorter side. And then we take that height and times it by the base and divide by 2. Our area is 389.7 units squared because the units are not specified. For question number 7, you needed to find BD, the longest side of the bottom triangle, and then use that to find that shorter side AB. For number 8, before we find the height, we need to find the missing base of that smaller triangle. So use Pythagoras' theorem on the larger triangle, and then minus 3. If you read the question properly, it gives you the hypotenuse of the smaller triangle. So use Pythagoras' theorem on that and you find the height. Well done if you got some or even all of these correct. These are very difficult questions. Anyway, that's enough for today. You have made it to the end of Pythagoras' theorem. This has been Maths with Jade. If you enjoyed this video, please do hit the like button and subscribe to my channel to not miss out on other maths tutorials. Feel free to share this video to somebody who you think might find it useful and comment below and I will try to respond to all comments. Thank you so much. Have a nice day.